So this is asking us to think the other way. They are giving you information about the graph, and you need to figure out what the equation would be. These always make more sense to me if I graph them so I can visually see what's going on. So I'm going to just do a sketch. It's not going to be a whole graph. But we want the standard form of an equation of a parabola with a vertex at the origin, so we know the vertex is still here. And it has a focus point of 8, 0. So that means we're out here somewhere over 8 up 0. That's my focus point. So that tells me right away that I can draw in the parabola has to face this way. So of my options, I'm going to write them up here. I have x squared equals 4py is one equation we talked about, or y squared equals 4px. If you look at what's in control based on what this looks like, this tells me that x is in control, which means I need to pick the formula that has x not squared to the first degree. So this is the formula I want. And I can figure out what p is just by looking at the graph. P is how far out we moved from the center to get to the focus point. P is going to be 8. So then you just take that and you plug it into the equation for where the p is in the equation. And you're going to get y squared is equal to 4 times 8x. Your equation is y squared equals 32x. These shouldn't be too bad. Alright, so if we look at the next one, it says find the standard form of the equation of the parabola with a vertex at the origin, and the directrix is y equals 11. So if I graph this, I know I'm still at the origin here. The directrix is somewhere up here at 11. So then I need to think about what direction that parabola is going to face. It always faces away from the directrix. So the parabola would face down here, which tells me which variable is in control if it's facing down. That should tell you that y is in control. So if y is in control, I'm going to write down what the y in control formula looks like. That is going to actually start with x squared. X squared equals 4py because we want the y to not be squared since y is in control. It's a not squared variable that's in control. And then we need to figure out what p would be. P is how far it would be to get to this focus point. Well, we know to get to the directrix it would be positive 11. The focus point is just the other way. It's negative 11. So that's what we have to plug in for p into the equation. It's going to be x squared equals 4 times negative 11y, which means the equation is x squared equals negative 44y. Alright, this next one, they actually give us the equation already, but we have to pay attention to what we have and what we're missing right now. So right now, just looking at it, we can determine what's in control. That's one thing that we do have. We know that since it's facing up, y is in control, which means I want to use the equation x squared equals 4py, so that y would be the not squared variable in the equation. But then here's the weird part with this one, is for this one they don't tell you what p is, and you cannot assume that you know the focus point is here. There's no guarantee that the focus point is there. It could be here, it could be here. We don't have enough information to know where the focus point is. So instead we do have to use what we do have, is we know that this point lies on the parabola, and a point gives me two letters. It actually does give me x and y. So I can plug those into the equation and figure out that way what p is. So this is going to be 3 squared equal to 4p, that's what we're trying to find, times y is 6. And we get 9 equals 24p. And we can go ahead and divide by 24, and I'm just going to simplify that. That's y equals 3/8, or p equals 3/8. So then we're just going to take that and plug it back into that original equation to figure out what our equation is. X squared equals 4 times, we now know p is 3/8 from using the point, y, and then we're just going to simplify that. That's going to be 3/2 y. So there's your equation. The last types of problems we're looking at today are some real-world application problems because parabolas are all over the place. So this is just a couple instances where parabolas are super important to things in architecture and to things physics related. So if you look at the suspension bridge, that the chains in there end up making a parabola shape, or an arch bridge. Those are both helping to keep the structure of that sound. And then the other really big spot that you'll see parabolas is with lenses, both in a flashlight or a light of some sort. Also in a camera lens. Also, you could see it with a satellite dish. Those have a parabolic curve on the inside of them. So we'll look at a couple of examples on the next page. So here on this page, it says the reflector of a flashlight is the shape of a parabolic surface. The casting has a diameter of 8 inches and a depth of 1 inch. Write an equation of the parabola with its vertex at the origin that models this scenario. So I already sketched this out for you. We just need to fill in what we know. We know that the diameter of this reflector, which is this curved part here, that's the reflector, that's 8 inches. And we know that it's 1 inch deep. We want to write the equation. So this is another instance just like the last problem where we don't know what P is right now. I don't know how far out that bulb is supposed to go. But what I can figure out is I can figure out the coordinates of this point over here. I know that that point would go over half of the diameter. That's actually the radius, quote unquote. So that would be over 4 and up 1. So now I have a coordinate and I know what direction this is facing because it's facing up. That tells me I want to use the equation where y is in control. So that's going to be the equation that starts x squared. X squared equals 4py. And we can plug in, I know x is 4, and I know y is 1 from my coordinate. So I just took those values from this coordinate here, and I plugged them in for x and y. And then I can solve 16 is equal to 4p, which means p equals 4. And then I can plug that into the equation, and we get x squared is equal to 16y. So that is the equation for the parabola. Part B is an interesting question. It says, how far from the vertex should the light bulb be placed? So if you look at that there, what we're trying to figure out right now is where this light bulb should be placed here. Well, the light bulb is going to be placed at the focus point. So you need to realize that they're asking you how far out that should be to get to the focus point. And what I need you to make the connection between is what letter in the formula gives you the focus point. The focus point we figure out how much to move out just by finding P. So they're asking you for in part B right here is they're just asking you for P, which we found in the last problem. So that would mean that it's going to move out 4, and we'll put units on there. We move it out 4 inches, that's where the focus point would be. So one more word problem. This one we have to draw ourselves. So it's a satellite dish is in the shape of a parabolic surface. Signals coming from a satellite strike the surface of the dish and are reflected to the focus where the receiver is located. A satellite has a diameter of 12 feet and a depth of 2 feet. So what this looks like, if you have never seen one of these really large satellite dishes here, even the ones that you have, those of you who have satellite TV, it looks kind of like this as well, is there's a dish here that is parabolic in shape. But what I need you to realize is there's this receiver guy out here, usually with like a little box, that this is where actually the information comes in, it bounces off here and goes to the receiver, and that's how you get your TV or whatever message or information you're trying to get. So, they want to know, let's fill in what we do know. They told me that the diameter, we've got that again, the diameter is 12 feet. And the depth is 2 feet. We want to write an equation to model this. So this is the same kind of thing as the last one, is we want this point. That's what we can figure out. You know, that's over 6 up 2. And then I know since I drew it this way, you could draw it the other way if you wanted to, but I drew it with y but is it facing up, which is in the y direction? That y is in control. So it's going to be the equation x squared equals 4py. And I can plug in that x is 6, and that y is 2, and that's 36 equals 8p. And then I'm dividing by 8, and you get p is equal to 4.5 if we change it to a decimal. So then to get the equation, I've got to take that and plug it back in. That's x squared equals 4 times 4.5y, which means x squared is equal to 18y is our equation. And then part B is usually going to have you do something with that equation. It says, how deep is the satellite dish? I'm going to change this 3 feet. But then that said 3 instead. 3 feet from the center. So if I want to go 3 feet from the center, we need to think about what direction that's asking me to go so I can figure out where to plug that in. 3 feet from the center is asking me to go this way. And then I want to know how deep it is, so I'm actually looking for y. How deep is y? 3 feet from the center is x. So all we need to do is plug that in. It's going to be 3 squared is equal to 18y. And then that's 9 equals 18y, and I'm going to divide by 18. That tells me that it is a half a foot deep. 0.5 feet is how deep it would be if we move 3 feet out. Okay? So I put 2 problems on ClassKick for you guys to try. I'd like you to do those. And then there's also the homework problems. I'd like you to try those. Those are due by the beginning of class time on Monday. So please just make sure that you try those before then and that you submit those so I can give you really a free 2 points. And then I need you to make sure you fill out the Google form first thing Monday so I know which ones we need to talk about. We will continue talking about parabolas. We got a little bit more of the notes to finish on Monday. And then we are working towards an in-class assignment next week. Okay? Keep up the good work. We've made it through our first week. 2 more to go, guys. We can do this. Love you all. Have a great rest of your day.